All right, we still have people rolling in, but I'm going to welcome you officially here to our fall SoDa Symposium series. And I'm Folke Bernadotte. I'm one of the two co-directors of the Social Data Science Center here at the University of Maryland. And it's my great pleasure to see, just like we had in the last semester, so many participants here from a wide variety of backgrounds. We look forward to getting all your questions later on in the open discussions. And be aware that the webinar is recorded. So in case you have privacy issues or what have you, then at least you know that recorded are only the slides and the videos of the presenters. So no worries on that front. Okay, so with that, a very warm welcome to our first speaker in the fall series, Ernesto Calva and his team. Ernesto is a professor in government and politics and the director of the Interdisciplinary Lab for Computational Social Science. In my perspective, a field that has been around for a long time, but it really is very visible that a lot of universities are starting programs entitled Computational Social Science. So a growing interest, I think, overall. And so I'm particularly delighted to hear Ernesto showcase a whole bunch of projects that he and his teammates that he will introduce are doing. So I'm handing this over to you, Ernesto, to guide us through this very exciting afternoon.
Thank you so much. Thank you so much for the invitation. And I'm joined here by Professor Jóhanna Birnir, who's the co-director of the center, and Thiago Ventura, who's graduating soon enough and going to in the civic integrity unit at Twitter. And another one of our graduate students, Henry Overos, who's working in the AMR project. And we were interested in showcasing a few of the things we're doing in the lab and showing how they connect to SoDa. So we want to thank very dearly all the SoDa colleagues that have invited us to share our research. I need to share here. So I'm going to share a PowerPoint. And introduce some of the things that we're doing. And we're going to go relatively fast, showcasing different projects. And hopefully we're going to be able to have a Q&A that is rather extensive. So we're going to move relatively fast. So let me first tell you a bit about the lab. We are a consortium of different researchers, so we're all coming from political science. We're concentrating in GVPT, but as we have grown, we have some of our former students and associates that have been also opening sections of the lab in Argentina and Mexico, and we've expanded the set of partnerships with whom we're working. So Paula Clerici is in Argentina, and Sebastián Vallejo Vera, who was a graduate student also of GVPT, is now leads the lab in Mexico. And then we have a very clear research and training mission that is organized both to meet social computational social science demands, but also to connect that with a survey methodology and to be able to identify relationships with small data and not just with big data. And we're going to show a bit of what we're doing. We concentrate on areas of social media consumption, big gaming, social media gaming, and AMR, research on gender and ethnic identity and minorities at risk. We're going to be showing some of those projects, and we have a large number of partners that we've been working with. That includes fact checkers in Latin America, like TAM Chequea and Chequeado. That includes also other educational institutions in Latin America, from UNSAM to FGV in Brazil, in Argentina. Gaming companies like EVE, that Jóhanna Birnir is going to be talking about. The Inter-American Development Bank, where we work on issues of social media and trust. So we have different partners both in industry and in academia with whom we've been working. But we are mostly a research and training institution, so we've been very selective on choosing partnerships that actually advance the research that we're interested in. Most of the research that we work on, as I was saying, connects big data and small experiments. So the way in which we generally work, and we're going to show very different projects that take the same kind of perspective. We start with big data, and we analyze, we download data from social media, we download news media from dashboard, we scrape data, we connect with, as I was saying, gaming companies, with all sorts of sources of big data. But then we move from the big data, we extract resources, we identify processes that we're interested in, we take information from the big data, and we move that into the lab. So a lot of that, what we think of what we do is similar to what you're seeing here. No? So for example, we have a network, and from the network, we extract some misinformation that might be in the network. We bring this misinformation into the lab. We tag, we modify, we moderate this type of content and introduce them to different kind of users in the lab. And we try to evaluate to what extent they share the content, they amplify the content, and what makes social media messages propagate, and what makes, when we analyze gender relationships, identity politics, streaming chats, in all of the cases, we're trying to see to what extent what we observed in the data is also replicated in the lab and gives us insight into how it works. So consider, for example, this, we have in social media, we download large numbers of data, large amounts of data, and that includes, for example, Twitter data. And in Twitter data, we try to see to what extent people amplify different types of messages. We have, for example, on the left, the assault on Congress in January 6th, and we have Republicans in red, and we have Democrats in blue, and everyone is connected in social media and is producing social media messages. And every social media message that we analyze in Twitter, a large part of the tweets are, for example, retweets. So there's a distance, a time to retweet that we can model, and that we can analyze to see to what extent people are more engaged or less engaged with whatever event we're analyzing. So in this case, for example, more engagement, faster engagement means that the line is going down. It means it takes less time to retweet, to amplify the information that we are considering. And we, for example, have two very different events on January 6th. One, which is Trump's speech, which Republicans are following, and another one, which is the assault on Congress that Democrats are going to be engaging with. And you can tell that there's a big difference on the moment in which suddenly we have a critical event. So, for example, the beginning of Trump's speech, in which Republicans suddenly, they become much more active, and the time to retweet declines dramatically, and we have this continuity. And the Democrats, on the other hand, that are tracking what is going on both with the Trump speech, but also what's happening in Congress. And so only as the assault on Congress starts, we have a discontinuity on their side. And one of the interesting things that you might see is that the discontinuity on the Republican side when Trump starts to speak has no correlate at the same time with a discontinuity when the assault on Congress starts. So there is no discontinuity here. There's a big discontinuity on the Democrats when the assault begins. Consider also, for example, another example on the right. We have the Republicans in red, we have the Democrats in blue. Trump only announces that in a tweet that he has become infected with COVID-19. At the moment that Trump posts the tweets, there's a huge discontinuity. Both Republicans and Democrats are immediately talking about the tweet of Trump and retweeting information, retweeting content related to COVID, but the effect is much more dramatic among Democrats that start to retweet much faster than among Republicans. So as I was saying, what we do is we take that type of information and we bring it to the lab. With fact checkers in Argentina, as what you're seeing here, for example, we analyze the same kind of discontinuity when a social media post that is false is suddenly declared as being false by the fact checker. We then analyze the discontinuity on the observational data, but then we take the fake post, the false post that is circulating, and we put it in the lab. And to some, for example, survey respondents that we have, we show them the adjudication of true, and to some of them the adjudication of false, and we see to what extent they are amplifying the messages to a different extent. And of course, all of this is done with IRB approval and ensuring that there are no sensitive issues or problematic issues that are, where information that is false that is being put outside. But at the same time, it's important to notice that information that is adjudicated as true and adjudicated as false false, when we observe the same information in the lab, we have very different reactions. And for example, we can see that adjudications that are true are amplified much more readily by the group that is cognitively congruent with the content, but the adjudication of false just depresses dialogue in general. And by looking that in the lab, we can not only see what happened with the observational data, but also to what extent moderating that and modifying the frame elements that we have in the tweet, we can see different effects, and we can understand better how content is propagated. Once we have this information in the lab that explains some of the behavioral elements that we care about, then we go back to the observation data. And in the observation data, we can obtain, these kind of matrices from Twitter data, from news sharing data, from all kind of messages that are being amplified. And we can see information that is produced by certain news outlets and information that is amplified by certain users. And we can analyze the embedded links that we have in any data set, or hate speech that we have in any data set, by considering what things are more frequently shared, what users are more frequently sharing some types of information or all types of information, to what extent some users are only sharing things on the left, or they're only sharing things on the right. So imagine, for example, that we have here the New York Times, and we have here Fox News, and we have that these news outlets are being amplified to a larger extent than, for example, M3, that is being amplified to a much less extent. So from this matrix of embedded links, we can extract information about issue salient. What are users talking about ideological congruence, what users are talking about which types of information, about the reputation of the media outlet, or the prevalence of hate speech, so that we can see what terms are more likely to be amplified in different types of media. So what we do is we start with observational data, we put some of that observational data in the lab, and once we have information that we can work with and that is interesting, we put that information back into the observation data to produce better models that describe how politics works. So a lot of what we're going to be showing you shows the same kind of characteristics. So I'm going to pass to Thiago Ventura, who's going to describe some of the work that he's been doing on streaming chats and social media.
Yeah, thank you, Ernesto, and thank you for the SoDa community to have us here. So my name is Thiago. As Ernesto said, I am a grad student at GVPT, and I have been a researcher at iLCSS probably since the start of the lab, so a few years ago. And today I'm gonna present a different project that I have been working for the last 2 years with some colleagues from other universities. And we started this project as we were all participating in the Summer Institute in Computational Social Science. And that's where we started developing this project. And this is a project that pretty much goes on the same direction of what Ernesto was saying, this combination of social media data and experiments, but with some particular things that we changed on this experience that we are running. The main thing here that's different from what Ernesto showed is that we are here more interested on working with different social media platforms and different new technologies that are not just Twitter and Facebook. And that's where most of our field is concentrated in computational social science and communication and political science as well. And we are also interested here in this paper on combining not small lab experiments with social media data, but actually a large field experiment that was implemented online with social media data from these new technologies. So the main goal of this paper that it's actually a forthcoming paper in the Journal of Communication, but we have like some other projects related to this. But the main goal here is to understand the behavioral effects of streaming chats, and even like more broadly, what streaming chats are. Streaming chats are this new technology that allow a media broadcaster to broadcast video at the same time that they are allowing users to interact with the content that is shown on this particular video broadcast. And this is an image of the presidential debate of last year between Biden and Trump. And for the presidential debate, for example, all the 3 debates, they were streamed on Facebook page of the main media broadcaster in the US, and they were all streamed with the video and the chat box by the site. And what we try to understand on this particular research project that I have with some other colleagues is exactly what are the effects of consuming information on social media through video and at the same time being exposed to this particular set of comments. And the way that we did that was we ran a field experiment where we recruited users from MTurk, and we asked them if they were willing to watch the primary debate. It was not the presidential debate, so that was 2019 on the Democrats, and if they were willing to watch the debate, if they had a Facebook account, and if they were willing to join an experiment. And for the answers, for the respondents that said yes, we basically assigned them to 3 different experimental conditions. So this is the field experiment part of our work. And we assigned them to watch the debate on the NBC website. Can you just come back, Ernesto? So to the NBC website, to the expert chat that is like 538 with the video and some expert comments, political scientists discussing the debate, and the streaming chat. That is exactly the image that I'm showing here with on Facebook with the video and the chat box that is open to all users to make comments. Now you can go, Ernesto. And then we did the observational part of the work that is understanding what streaming chats are. And we scraped data from Facebook page, from NBC, ABC, and Fox News that show the debate. And we throw this data on a deep learning classifier that was developed by Google to first understand what are the levels of toxicity and the characteristics of the comments on this particular chat box. And we found we have several different analyses in our work, but the most important thing here is that close to more than 15% and close to 20% of the comments that we collected were classified as insult or toxic. So those are chat boxes that are particularly toxic and particularly full of hate speech that people are exposed kind of incidentally as they are watching some video content and media broadcasting. Can you jump past Anderson? And then we, after analyzing what the chat boxes are, we actually measure the experimental effects for our follow-up survey after respondents watched the debate on these different platforms. And 2 things are super important here. We found that when comparing the Facebook experience with the NBC experience on the NBC website, respondents thought that the debate was less informative, less enjoyable, also less engaging, and they also reported being angrier and more anxious about what was happening in the debate. This is not statistically significant, but the sample was quite small and actually show like an important change of Facebook experience, like affecting how users perceive the debate. And also more important here, comparing the Facebook experience with the NBC website experience, we saw a decrease on the feeling thermometers towards the candidates, particularly towards Kamala Harris and Joe Biden. That when we combine this information with our text analysis, and you can go to the next slide, Ernesto, we actually show that there is a strong correlation between the reduction on the feeling thermometers and the amount of negative and toxic comments that were made in the chat box towards Harris and Biden, but also other candidates, for example, as Beto or Hooker. So this is like one example of the kind of research that we're doing at the iLCSS, and it's this experience of combining experiments and social media data and finding and answering questions that are relevant for our understanding of how politics play a role on these new technologies that go beyond just Twitter or Facebooks that are the more traditional ones investigated by political science and computational social science scholars nowadays. So that was like my presentation. I'm gonna pass to Professor Birnir now to talk a little bit more about our research on identity politics.
Thanks, Thiago, and thank you to the SoDa community for inviting us here to talk about our work. So another one of our substantive umbrella topics in the lab focuses on gender and politics, and we have several projects that fall under this hat. And like our other projects, the hallmark of these is that they combine novel data sources with sort of more conventional ones for the purpose of triangulating the testing of our theories. And the first of these projects that I'm going to talk about here examines gendered behavior and attitudes across virtual and real worlds. And for the data on the virtual world, we rely on EVE Online, which is a massive multiplayer online role-playing game. In EVE, gamers can play characters of both genders, and the data that we have is time series data that includes attributes and actions of every character that's played, including their gender. Our first working paper on this topic reveals some interesting insights, such as the one that's displayed in the graph here, that shows that men and women play characters of the opposite gender very differently. Specifically, when players play characters of the opposite gender, they seemingly rely more heavily on stereotypes of appropriate activity for that gender. And in contrast, when they are playing characters whose genders corresponds to their sex, the variance in their behavior increases substantially. So they seem to engage in a lot different behaviors depending on the gender that they choose for their characters. Can you go to the next slide, Ernesto? We then paired these data with survey data that we're running in Indonesia, and our survey asks questions that have been asked in similar surveys in India and Thailand, so we can compare across countries. But in addition to sending the survey to a representative sample of the Indonesian population, this is a survey on gender issues, obviously, we're also surveying and interviewing Indonesian EVE gamers to better understand how what we see, the information that we're gleaming from the game on gender, how and if that corresponds to answers that the public is giving at large. Another one of our projects that falls under this umbrella is a study of an online forum where aliases are randomly assigned names. And because everyone that contributes knows that the pseudonyms are randomly assigned, there should not be any gender effects in evaluations of content on this forum. What we're finding, however, as you see in this graph, is that despite the random assignment of names, there is a persistent gender effect in that contributors with female names get consistently evaluated more harshly than their male counterparts. And furthermore, we're finding that contributors with female names are systematically punished for engaging in behavior that is stereotypically associated with or is thought of as more permissible for males. So for instance, if contributors with female names are assertive or emotional or emotively negative, they're evaluated disproportionately negatively. And this is despite the fact that everybody entering into this forum presumably knows that the names are being randomly assigned. Changing gears a bit, but still with a focus on identity, AMAR that Ernesto mentioned earlier in his presentation, or the All Minorities at Risk project, is another one of our sort of umbrella projects. It's a large data collection on ethnic minority and majority behavior and treatment, and that is housed in GVPT. And it's the independent successor of Ted Gerst's famous minorities at risk data that many of you may be familiar with, but it's about 3 times more expansive with respect to included groups so as to accommodate a wider range of increase. The AMAR sister data collections that we also collect include the GeoAMAR, where we have geocoded all 1,200 plus groups in the data, and the A-religion data, where we code every ethnic group for religions and sects. The AMAR data then form a part of a number of projects, the most prominent of which is SCAR, or the Studies in Comparative Anti-Racism. Can I get the next slide, Ernesto? SCAR is a collaborative project with researchers at the University of Michigan, UT Austin, and Howard University. And like our other projects, SCAR combines multiple interesting data sources in an attempt to answer our research questions. Within SCAR, for example, this summer we took part in a critical issues survey where the objective of our questions was to assess how the public currently views political, economic, and cultural discrimination against identity groups in the United States. Now, we're just beginning to go through this data, but as you see on these graphs that I've included here, assessment of Black discrimination, for instance, seems to look different than the assessment of discrimination against other groups in that it's distinctly more bimodal. Furthermore, in assessing discrimination ethnic stereotypes, such as the idea of Asians as the model economic minority, seem to be alive and well. And we're finding lots of interesting observations in the data so far. Next slide, Ernesto. Furthermore, when it comes to proposing solutions to discrimination, the American public still is resolutely promoting hard work and legal options and discounting protests. And this came as a real surprise to us because this survey comes on the heels of all of the Black Lives Matter protests. So to dig further into these issues, we are combining insights from this polling with new techniques in text analysis, and Henry is going to tell you a little bit more about these. Henry?
Thank you, Jóhanna, and thank you to everybody. So continuing with the discussion of the All Minorities at Risk data project and SCAR, if you think about the utility of this data, you also have to think about some of the problems that arise when you're trying to maintain and expand it. So this is a large data set. The scale is enormous. We're looking at not just analyzing groups in every country, so there's geographic variation, but there's also temporal variation because we're trying to track them over time. This is just a subsample here in this heat map on the slide of 4 countries and some of the prominent ethnic groups. The heat map is measuring political discrimination. So there's significant variation across countries and across time for all of these groups. Trying to maintain all of this information is difficult, especially because AMAR was originally created just with hand coding and reading news articles and other open source reports and forms of information. But what we want to do in relation to the more small experiment survey methodology that we're working with to explore these same questions is to find a way to get close to real-time analysis of political discrimination so that we can examine the environment that people are being surveyed in and be able to ask better questions about it. So to keep this up, what we've decided to do is look at quantitative and computational tools that could help us to better, more efficiently analyze a lot of text about a lot of different groups. Ernesto, you can go to the next slide. So our solution has been computational text analysis, looking at newspaper data. Our first application was in the United States. We downloaded over 400,000 newspaper articles between 2016 and 2017. We then converted this collection into analyzable data that we applied a machine learning algorithm called NewsMap to in order to tag the articles by the AMAR ethnic group, as well as by political actions as defined in the AMAR data project. So in this example here, we tagged articles based on the US groups in AMAR, as well as whether or not an article was about mass demonstrations. And what we found was very interesting on a couple of fronts. So first, just for being able to analyze and encode for the political behavior of groups, we can see large spikes where we should predict there to be large spikes in articles about mass demonstrations. So Black Americans, you can see a large spike in that yellow line there. That is actually corresponding with one of the first national Black Lives Matter protests. Similar things appear in Latin America or with Latin American protests whenever there's discussions about Trump building a wall or closing the borders to certain countries. You see spikes in mass demonstrations by those groups, and that is showing up in the news that we're tagging. One of the other things that you'll notice, and this is kind of going back to Ernesto's discussion of what we can do when we're analyzing this, not only text data, but the metadata around it, the counts for the different groups are significantly different in the same time period, which is telling us that there's a large amount of variation about coverage of groups and group actions. And we can combine this with user and share data through social media to analyze what makes these kinds of movements salient or not salient and to whom it matters. So that's all I have for the AMAR section. I'll go ahead and give it back to Jóhanna. Thank you for your time.
So that brings us to our final bullet in this presentation, which focuses on our graduate students. Henry and Thiago, of course, are two of our advanced graduate students that are working in the lab. Like Thiago mentioned, he's been with the lab from pretty much from the beginning. And one of the main points of pride for us in the lab is that we have developed a very robust peer mentoring network with our graduate students. Both Henry and Thiago benefited from the tutelage of students working with us as we were founding the lab, students that have now gone on to assume faculty positions at other universities. And Henry and Thiago, in turn, are playing an instrumental role currently in mentoring students in the program. And those students then are expected to take part in mentoring incoming students. And we've been trying to build infrastructure and information, share information that allows this to happen. And we feel that this has been a very successful experiment. A second point we think that differentiates us at the lab from more traditional social science training is that all of the work that we've been talking about today is done in relatively large teams involving a number of different students and professors. And this is pretty different from the typical social science model, at least in political science, where you often see 1 or 2 senior scholars working with 1 or 2 RAs. And as a consequence, we feel like we're developing a very dynamic collaboration that we think benefits both the younger scholars that are entering into the field with great enthusiasm and innovative energy, and sort of the more established scholars that are working on these topics. And on that note, I will repeat Ernesto's thank you for having us and open up for questions.
Thank you so much.
Thank you also from my side. I want to say this is fantastic. And I failed to tell everybody there's this Q&A feature at the bottom of the Zoom talk, which you probably all have used given the time we've spent on Zoom. But please type in your questions. And while people are typing in their first question, I want to touch on something that you said at the very end in terms of teams. I mean, Julia Lane, who was part of the SoDa Symposium a while ago, she once said, data science is a team sport. Sounds like that's very much true for your teams. Could you describe a little bit more the backgrounds of these different team people? And I see my teammate Brian Butler here. That's excellent. You can just follow on the questions soon. But can you describe a little bit where they come from? And if someone wants to enter this field of computational social science, you know, what should they bring with, or with whom should they partner?
Should I start, or do you want to start, Ernesto?
It's fine. Sure, go ahead. I'll add later.
So the way that the teams work in the lab is that we are, first of all, trying to get everybody that enters into the program that is interested in participating and interested in getting this kind of training up to speed. There's some sort of basic training that's necessary that everybody has to get, and we try to make sure that we consult or we sort of advise our students with respect to what classes they need to take, and where outside of the department they can get sort of the basic skills that they need. And then what we find is that people, graduate students and the professors also tend to sort into teams based on interest. We try to broadly introduce our graduate students to a variety of different topics and techniques, and then people sort of sort into teams based on their interests. So in the AMAR project, for example, I'm working mostly with Henry, Oja, and Jordan, all of whom are interested in issues of about identity. Henry's writing a dissertation on religious minorities. Oja is interested in LGBTQ issues. Jordan is interested in issues of ethnicity in the Balkans. And so, that's how the teams come together. And then in the team, we have people at various stages of training. So among the graduate students, Henry is the senior graduate student, then there's Oja, and then there's Jordan. And then Henry helps in the training of Oja. Oja helps with the training of Jordan, and so that's sort of how we build the teams. I see Thiago wants to add. Go ahead, Thiago.
No, just like one general comment about this, and I think that's a good place to share this, is that one challenge that we have is how this is something new, particularly in political science. And we have like to balance the fact that like most of our work is like in teams, and our discipline still value like solo authorship and two authors too much for the kind of work that we do in a lab like ours. So one challenge that we have, and I think that this is a challenge for the future years, is to show that like as we move to a discipline that is doing like more data work, more like lab experiments, and doing like things that are more common in what I'm supposed to call like the hard science, we also should acknowledge that the kind of publications that we are putting out are not going to be like solo author, or even like dissertations are not going to be like a full book style type of dissertation. So that's a challenge that we have for the future years, and that's what we try to do in the lab as well.
So let me also add, so we do encourage consistently that our grad students take some of the data, some of the experimental results, and that they work their own publications and with peers and with us at different rates, so that they can have a balanced portfolio of the kind of things that they're doing. But also I think that the labs, what it does provide is an opportunity to get resources and to get data and to do things that individually would be very taxing for our grad students and not just for faculty. So for example, the agreements that we had with the IDB and with Chequeado allow us to produce already 5 different surveys. And in those surveys, we can test critical things. So for example, again, just like Hannah was saying, in our case, in the area of social media, we have Thiago, and we have now 3 new grad students, Flavia, Juan, and Pedro, and we are both, shifting resources so that they can advance their own research agendas, but also trying to introduce instruments in the surveys and in the data collection effort, so that eventually, by the time that they get to the 2nd and 3rd year, they can produce output that is valuable. Research not only has become faster, more of a team organized activity, but also publication times have become longer, and that affects our grad students. So the fact that we have a pipeline of research that is moving forward means that our grad students have a pipeline of data and problems that they can work with, and that makes everyone more competitive. And I think that these kind of issues are going to become way more prevalent. We did an article analyzing COVID publications, and of course, the number of publications on COVID, the number of articles written on COVID is now reaching 250,000, 260,000. Of those, we have a good 10,000 in political science. So we have hundreds of articles that are being published or that are being produced, and many of them published every week. So the publish or perish has become much more of a fast team, publish and perish. And that also requires responses from faculty, from students, from labs. So I think that what the iLCSS is also providing is an area where students can bounce ideas, can bounce instruments, can get access to data, and not wait until the 2nd or 3rd year to start to think where they're going to get the materials and how they're going to go ahead and produce their dissertation and their publications.
And also, if I may add to that, in this way, we can involve students into the publication process and grant proposal writing process right off the bat, and not have them wait until they're later on in their careers to sort of see how that process works. So I think that's another benefit that comes from this. But as Thiago said, I mean, it's challenging, and given that this isn't the convention in political science, you sort of have to have a couple of senior people that are willing to forego convention and put themselves last, because that's not the convention that we're used to seeing in political science. So
I see there's also a question on what software programming language do you use? And I would say for the lab, close to 80% of what we do is R. We do have some big data collections that are conducted in Python. So we have a few accounts on AWS where we conduct some bulk data collection, and generally all that is in Python. But all the estimation and what we invest more heavily, because we have such an emphasis on modeling and producing sensible results rather than scaling up, we use way more R than we do Python.
There was also an earlier question that was actually looking more at, I think it was responding to your description of some of the modeling work you're doing, where they were asking, actually I'll just read the question. Do you consider somehow the selection bias embedded in the data when you do back to modeling stages? So I think that's a general question of bias in the data, and how do you address that and think about that?
I think that there are two things. One, I think it pertains particularly to what Thiago was presenting, and they were asking about the pool of the users that were seeing the streaming chat because it was a field experiment. So maybe Thiago, if you want to answer that, and then I can talk a bit about the experiment.
Yeah, sure. So there are two different types of selection issues here in this field experiment. One is planned in some sense, and the other one is more related to attrition that we try to monitor using different strategies. The one that is planned is that we decided to target a population that is likely to be exposed to the technology that we are interested in. So we don't make any argument in the paper that these effects are general to the entire population, because it's not the entire population that consumes streaming chats or that actually watch like media broadcasts through this kind of new technologies. So that was actually a decision. We made a design that would recruit people that were more likely to be exposed to this particular new media technology that we are interested in. So in this sense, you can imagine that these effects are all local, and they are related to the population that we were targeting to begin with. And the other one is attrition, and that's always an issue with food experiments. And what we try to do is so the best solution would be to have some kind of web browsing data. We didn't have money for that. That's something that we are planning to do in the future field experiment that we are running, probably in Brazil, if you get the grant that we applied to actually check the attrition with web browsing data. But since we didn't have web browsing data here, we monitored the attrition with survey responses. So we had like several different survey responses about where did you watch the debate. And then we provide in the paper responses that are both ITT, so intention to treat, and also complier effects using these different survey questions that we have. So that's basically how we did.
And to complement two things, on the browsing data, we're also collecting that in the survey on fact-checking in Argentina, precisely to deal with, well, both information that comes that way and attrition. And in regards to other biases, that's why for us it's so important to combine observational data and experimental data, where we can have internal validity and we can have a population that is fully randomized as we conduct the experiment. So, for example, one area where this makes a huge difference is in social networks, because of the huge selection issues that you have in network connectivity. So when we bring this into the lab, we can control for the equivalent to the topology of the network. We can take that out of the equation so that the exposure to social media can be controlled. So that's why I think that combining observational social media data, where you have always a network that cannot be parsed, that cannot be separated into pieces, to bring that into the lab so that we can observe those different effects is so important.
So
if the question was more generally about selection bias, just to echo what Ernesto said, we think very critically about selection issues across all of the data. So to give an an example from the data projects that I was talking about, the AMAR data is actually developed in response to the selection issues that were prominent in the original MAR data. And so it is the only large-scale ethnic database that is, with respect to the selection criteria, doesn't suffer from selection issues that sort of plague most other data sets on ethnic groups, in that it has a comprehensive selection frame, sample frame, sorry, for all groups that meet the criteria that were set out at the outset of the collection. And the same is true for the collection of data and across the virtual and the real world with Eve. One big concern is that gamers are somehow different from the population at large, and so that the types of gender effects that we're seeing in the online game are not representative of what we would see in the real world. And it was with that idea in mind that we developed the survey, and this idea of administering the survey to the general population and gamers with follow-up interviews to try to understand what the correspondence in gender attitudes is between gamers and the general population, so that we could account for any selection issues.
Yeah, the complementarity that you were describing, that actually all of your projects describe, of kind of using multiple methods and multiple sources of data, is a really powerful way to address, frankly, some of the risks and challenges associated with studies that are often, that are data science, but are really focused on one type of data. So I think it's a very powerful addition there, and obviously it's having benefits in terms of political science knowledge as well. One thing that I apologize, I didn't quite catch who mentioned it, but someone was talking about how one of the goals of one of the projects was the idea of being able to maybe even track some of these things in real time or closer to real time. And I was wondering if you could say a little bit about what you saw the value in that being. And I think it was the AMAR.
It was me, Brian. Hi.
Yeah.
Yeah, I was talking about that being a goal of ours when we were trying to update the AMAR data that Jóhanna laid out. We discussed the idea of it being either real time or close to real time. It's hard to get actual real time, but the way that we've been doing that is partnering with organizations that allow us to access to essentially like download a lot of social media data and texts from news articles that are shared online. And from that, we can sort of observe day by day what is being talked about in major news outlets and smaller news outlets, and then where that's being shared. So I think the advantage of that for us is, again, this is a large data collection project with a lot of different groups we're interested in. And so being able to just get that information as quickly as possible gives us more leverage when it comes to going back to the data set that we're going to be showing people and coding it accurately for each year. Jóhanna, I'm sure that you have thoughts on this as well, so I'll go ahead and let you jump in.
Just to add to what Henry is saying, so in the SCAR project, one of the things that motivates our data collection is the policy discussion following the Black Lives Matter movement, and the observation made by some of our colleagues that some of that conversation doesn't have a whole lot of evidence to use as a basis for decision making. And so we then started thinking about, well, how can we use some of our data collection efforts to create evidence that can be used as input in these decisions, policy decisions that need to be made fairly rapidly, responding to events that are occurring. And so, that's a lofty goal, but but that's sort of where we would like to see this data collection effort go, that if we can develop the model and it's a good model and we have it on variables that are largely relevant to contentious ethnic or identity politics, then we should be able to produce information, evidence fairly rapidly, which then can be disseminated and used for decision making.
And again, I think
one other thing, just kind of going along with that, one thing that we've noticed is that, for example, with Black Lives Matter protests, that is not just a national phenomenon, that is an international phenomenon that moves very rapidly. And some groups are successful in sort of taking those ideas from Black Lives Matter and pushing for change in their own countries, and other groups try and are not as successful. So one of the questions we're also asking is, how is, in this rapid environment of change for all of these different groups, is that success or failure of a movement sort of being talked about online, and does that play a role in the success or failure itself?
I think what you just described, Henry, I think was really interesting. There's certainly wanting to use the data and the tools to inform policy, to inform decision makers, but there's also what you're describing, which is that seeing things in real time potentially provides different kinds of questions, or results in different kinds of questions. It's sometimes a little harder to get to different kinds of insights, but certainly it prompts us to ask different questions than we sometimes do when we're looking at it in batches. So, well, are there any other questions from the audience, either in chat or in the Q&A? Okay. If not, I think we can wrap up. And again, thank you very much for the presentation, a really interesting presentation about the work, and both the work and how you go about doing it in your lab. I think those are both really valuable things to share with a broader community. Sarah or Jody, I believe we have, yep. So kind of in the same vein, we have some folks from the Measurement Statistics and Evaluation Program at the College of Education. Will be presenting in November on quantitative methodology with measurement, statistics, and evaluation, describing some of their work that they're doing there and how they're using the data science techniques to advance their work in education. And we would encourage you to join us for that. And then the next slide, please. I think we have one more slide. Oh, maybe not. Well, if we don't have another slide, the other thing that we were going to mention is, if this is something that's of interest to you, either as a faculty member or certainly as an undergraduate student, one of the things that we have that is coming online this fall and into the spring is a new major in social data science that currently has cognates. So you can do that, the social data science, in conjunction with each of the departments in BSOS and School of Public Health. And we're talking about doing that with other units across campus. So if these kinds of methods and approaches and ways of thinking were something that you found to be really interesting, and you're an undergraduate, stay tuned for information about the social data science major. And that's something you could potentially consider pursuing. And if you're a faculty member or a doctoral student, that's something you might consider teaching in or being involved in as that comes online over the next year. With that, thank you, everybody. Thank you very much, Ernesto and Jóhanna, for joining us and your team presenting your work, and everyone else for joining us. And we look forward to seeing you in the future.
Thank you so much for the invitation. Looking forward to that.